It's getting cold. Are you wearing thermal pants? For new energy vehicle owners, winter cold is even more painful. Range is reduced, charging slows down, and some even shiver without daring to turn on the heater. A lot of people jokingly call electric cars their electric overlords. The real issue lies with its core. The power battery is just too finicky. Too hot won't do. Too cold won't do either. The comfort zone is roughly between 15 degrees Celsius and 35 degrees Celsius. Too cold, lithium-ion activity decreases, battery internal resistance increases, discharge capacity drops. Too hot, lithium ions are too active and can easily overheat. At best, it shortens the lifespan. At worst, it can catch fire. To take good care of this delicate battery, engineers designed a specialized thermal management system. The mainstream solution now is liquid cooling. One of the core components is the water cooling plate, a plate with many grooves. Coolant circulates through the grooves under the action of a water pump. Open the car hood, you'll see a tank of pink, green, or purple liquid, which is the coolant. Water cooling plate, liquid cooling, coolant, all have cooling in their names, but the water cooling plate can also heat. In the scorching summer, the water cooling plate provides coolness to prevent the battery from overheating. In the harsh winter, the water cooling plate delivers warmth to prevent the battery from freezing. Designing the perfect water cooling plate is a real headache for engineers because it's full of conflicting requirements. First, the temperature difference must be small, as the battery pack has hundreds or thousands of cells. The water cooling plate should ensure all cell temperatures are roughly the same. So, you say if we want a smaller temperature difference, can't I design the flow path to be as complex as possible with many branches? That's not possible, because it also needs to have low flow resistance. Because liquid flowing through the grooves encounters resistance. Too complex and the water pump can't handle it, or it's too power consuming. In the past, engineers relied on experience to draw designs for water cooling plates and then used simulation software to calculate. If it didn't work, they'd go back and revise it. We all know the purpose of simulation is optimization, but this process can only rely on the engineer's experience. So engineers repeatedly draw and simulate. Who understands the frustration involved? Tianfu understands. To solve this problem, Tianfu developed the industrial software SuperBrain, the intelligent optimization design software AIPod, which can replace engineers in using CAD and CAE software utilizing multi-objective optimization algorithms. It seeks the optimum within design boundaries and can even appropriately break those boundaries, surpassing the limits of an engineer's design experience. To find solutions beyond, engineers only need to set up the process. Afterwards, the drawing, simulation, and optimization can be handed over to AIPod. A well-known domestic car company successfully optimized the water-cooled plate using AIPod. Initially, its flow resistance was 29.2 kilopascals, and the maximum temperature difference was 10.2 degrees. Through AIPod invoking KD for parametric modeling and CFD software simulation, adjusting parameters such as the width, length, and spacing of the flow channels. After 55 automatic iterations, the optimization results were very satisfying. Pressure loss was reduced to 23.4 kilopascals, and the temperature difference decreased from 10.2 to 8.9. No manual intervention needed throughout the process. Engineers can enjoy hot pot and sing songs. They came up with solutions that were previously elusive despite exhaustive efforts. Now car updates are faster, and the time allotted is increasingly shorter. Facing tough design goals and time constraints, who understands the engineer's frustrations? AIPod understands. From experiential design to AI-driven intelligent design, Tianfu has always been making engineering research and development smarter and more efficient.